Hello, Mrs. Leahy here, and I'm going to go through Unit 2, Distributive Property. So just to remind ourselves, remember the distributive property is how we multiply a sum or difference by a number, and we multiply each number in the sum or the difference by the number that's on the outside of the parentheses, and then we evaluate. So when we're taking a look at a number example for this, let's do the example 3 times 7 plus 2, and this would look like 3 times 7 plus 3 times 2. So where I'm coming up with this, remember, is 3 gets multiplied by 7, and then we add it to 3 times 2. So after that, we can then evaluate. 3 times 7 is 21. 3 times 2 is 6, and then we get 27. Now, I want you guys to look at the algebra example of this. So whenever we're referring to algebra, that's because letters are involved. So we have A times, I'll do B minus C now. This works for addition or subtraction. So taking your A times B, and then you have your A times C, but since it's a subtraction, you're going to put your subtraction sign, and you have A times C. So there's our final evaluation. So in example 1, using mental math, you can use the distributive property to find a number such as 8 times 53. So this is not something that you may know offhand. So what we want to do is we kind of want to break apart 53. So if it's something that is, so in this case, if it's less than 55, we probably want to round to 50. If it was over 55 and greater, then we would round up to 60, could work as well. So what we're going to do here is we're going to break 53 to be 50 plus 3. Now remember, I'm multiplying all of this is being multiplied by 8. So 8 times 50 plus 3. This helps us to be able to do a lot of mental math. Breaking up numbers with addition and subtraction helps us when we don't have a calculator or can't use a calculator. So now I'm going to use my distributive property of 8 times 50 and then add it to 8 times 3. Now again, 8 times 50 might be something that you think you don't know offhand, but since our ones place is 0, 8 times 5 you guys know is 40. So we'll add our extra 0 because it's 50, not 8 times 5. So now it's 400. And 8 times 3 we know is 24. So we can evaluate this to be 424. Okay? Now you can do the same thing when fractions are involved. So what we're going to do is we're going to rewrite 2 3/4 to be 2 plus 3/4. Okay, so if you think about money, if this was $2.75, you know that that's the same as $2 plus 75 cents. Okay, so I'm doing the same thing but keeping it in that fraction form. So I'm going to now take my 1/2 and I'm multiplying it by 2 plus 3/4. So I can use my distributive property. So I have 1/2 times 2 plus 1/2 times 3/4. All right, so now we know 1/2 times 2 is just 1 because our 2's cancel out to give us 1 over 1, which is just 1. And then now we're going to do our 1 times 3, which gives us 3, and then 2 times 4 gives us 8. Oops, I'm sorry, this should be an addition sign right here. So just as we broke down 2 3/4, now we're going to put our final answer back together. So if it's 1 plus 3/8, when we evaluate that, that's 1 3/8. Okay? Now, when we're looking at algebraic expressions and using the distributive property, it's really helpful to involve those arrows. So for example 3, I'm drawing in my arrows. 4 is going to be multiplied by n and 5. So 4 times n plus 4 times 5. 4 times n just becomes 4n, and 4 times 5 we know becomes 20. 4n and 20 are not like terms, so we leave it like that. All right, next up is example B. There we go, sorry. So we have 12 times 2y and 12 times 3. So we're using our subtraction. So I put my subtraction sign in. So 12 times 2y, so these are not like terms. However, remember with multiplication, you can multiply anything. So we're taking 12 and then we multiply by the coefficient of 2. So 24, and then we have our y. And then we have 12 times 3, which is going to give us 36. Again, these are not like terms, so we're done here. Oops, sorry. Now, the last one might look a little bit different because we're looking now at, we have three things inside, 3 terms inside of our parentheses. But that's okay. So one at a time. 9 times 6. There's addition, so we put our addition sign. 9 times x. I should draw it underneath so you guys can see. And then 9 times 2. Okay. 9 times 6. So we have our, and then plus 9x plus 18. Now, so far we've seen things that weren't like terms, so we stopped there. However, 54 and 18 are both constants, so we can end up combining those. So I'm going to rewrite our like terms together. You don't have to do this, it just kind of helps us to visualize. So now I have 54 plus 18. So what I can do is, let's think about 18 as being 20. So really quickly, I can do 54 plus 20 is going to give me 74. But since I added an extra 2, I can't say that the answer is 74. I need to actually take away 2. So now I'm at 72 plus 9x. It's just a little way to help with our mental math of just either rounding up or rounding down, and then remembering to take away the extra that you included. Okay? All right. All right, so next up we're going to look at example 4, which is a real-life application problem. So here we need to go through and kind of look at what everything is talking about. So we have Owen is X years old. We don't know how old Owen is, but we do know his brother Connor is 2 years older than, that should say Owen. Sorry. All right. Then it says their cousin Finn is 3 times as old as Connor. Write and simplify an expression that represents Finn's age in years. Okay, so we're talking about people here. So what I'm going to do is I'm going to categorize this part of the table as the names. And next I'm going to fill in, this is going to be our description. So how they're describing their ages. And then this is all about algebra. So we want to show that this is going to be where our expression goes. All right, so the names of these kids, first off is Owen. And what was described here was that he is X years old. Okay, so the expression is just X. Next kid is Connor. And he is 2 years older than Owen. All right, so 2 years older, remember this is referring to addition, because if you were 12 and your brother is 2 years older than you, they're 14. So we have X plus 2. And lastly, we have cousin Finn, that we were told he is 3 times as old as Connor. All right, so if you're 3 times as old as something, it's right there, times, multiplication. Okay, so 3. And times what? Well, he's 3 times older than Connor, and Connor is X plus 2. All right, so there we have our expressions. And so by using Owen and Connor's expressions, we were able to come up with an expression for Finn's age in years, which is what we were looking for example 4. That 3 times X plus 2. Okay? All right. All right, last but not least, we are going to look at combining like terms. So in an algebraic expression, like terms are terms that have the same variables raised to the same exponents. This is just as important because remember, something like 5x and 5x squared are not like terms. So, and also remember, we discussed this a little bit earlier with example 3, that constant terms are considered like terms. So what we did earlier was that 54 plus 18. That would be an example of constants. Okay, so they highlighted a little example here. So you have 5x and 2x are your like terms and 19 and 2. Just remember, they won't always be right next to each other, so that's okay. If they're on opposite sides of an equation, if they're not right next to each other in an expression, as long as you see those like terms, then you can combine them. All right, so with example 5, we're just going to practice our combining like terms. So whenever you're doing these, it's good to either underline, circle, highlight the things that are alike. I like to do that all the time. So let's start out by just underlining the like terms. So I have 3x and 2x that I'll underline in blue, and then I like to change it up so that now my 9 minus 5 is like terms. Okay, so starting out with 3x and 2x. If it helps you to put things together to visualize, that's good too. All of this is just optional. So now we have 3x plus 2x is going to give me 5x, and 9 minus 5 gives me that plus 4. And there you have it, 5x plus 4. All right, with example B here, what we're looking at is y plus 2, and then there's parentheses. So we have to reflect back to our order of operations. So if you remember, PEMDAS. And the very first thing is parentheses, but this is parentheses. Is there anything inside that can be combined? Okay, so right away I see y plus y. Are those considered like terms? Well, they're the same variable and they're raised to the same exponent power. They're both just an exponent of 1, right? Because y to the first is the same thing as y. So what we can do is actually combine that first. So now I have y plus 2. Now in parentheses is y plus y is a 2y. So I've kind of shrunken down what's inside the parentheses. So next would be exponents, which in this case I don't have any exponents involved in this problem. So then we have multiplication. So we want to do multiplication because that's what's next in our list. So we have 2 times 2y. So these aren't like terms, but we're multiplying. So we just need to multiply 2 times the coefficient of 2 to give us 4y, but I still have this plus y out front. So y plus 4y, are they like terms? Well, they're both the same variable to the same power, so we end up with 5y. Okay? All right, I think there was one more. Yep. Maybe. There we go. Sorry. Now, in this case, we're still looking at that PEMDAS. Let me kind of bring that so you guys can see it. Parentheses, exponents, multiplication. We'll fill in the rest real quick. Division, addition, and subtraction. So in this case, our parentheses, z and 5y, are not like terms. So we can't combine those first. So we move down our list. Exponents, no exponents involved. Multiplication. So when you think multiplication, you should also think distributive property. Okay, because that involves multiplying. So I see that right here. I'm going to do that in my green. I have 2 times z and 2 times negative 5y that I can do. So that would give me 2z, and then I have minus 2 times 5y. So we're just doing it in the form that we were working with earlier. However, we can't forget that we have this 7z in the original expression. So simplify a little bit. So I have 7z stays 7z, 2z now, and then here I can do negative 2 times 5y to give me negative 10y. So we're looking here, are there any like terms? So that would be the same variable with the same exponent power. So 2z and 7z, I can simplify to be 9z, but I am left with this minus 10y. There's no other y's. Z and y are obviously different variables, so that would be our final answer. Okay, So there you go. So now you guys can work on the assignment. If you have any questions, remember to reach out either through your messages on Canvas to any of the Lake Central Algebra teachers. Also, if you follow along on the instructions for this week, that will give you your specific teacher that is available and will contact you, respond to your emails within 24 hours. They'll also set up the Zoom meeting on Wednesday, and you can get on and sign up through that. So if you have any questions, please don't hesitate to reach out. All right, good luck.